Welcome to Kopernik Observatory. Glad you could join us today. Come on in, we're going to give you a tour of our facility. Walk in through the main entrance, and this is our main lobby. Normally when you come in, you would look immediately to your left and you'd see our store, and so you'd either show your membership card or purchase your admission for the event. We also have some Kopernik merch that you can buy, as well as some STEM toys. So usually what I do when I start a tour is I invite people to come right over here and talk a little bit about the history of Kopernik. So back in the 1970s, there was a group of Polish immigrants and people of Polish heritage right here in the southern tier that wanted to commemorate Kopernik's 500th birthday. I usually ask a quick question. Who remembers what Kopernik is famous for? He was also known as Nicholas Copernicus. That's usually what I hear. Not too many people remember, but Nicholas Copernicus, Mikołaj Kopernik, which is his Polish name, developed what's called the heliocentric model of our solar system. Up until Copernic's time, people thought that the sun, the moon, all the planets revolved around the Earth, but sometimes those planets looked like they were moving backwards. We call that retrograde motion. And that bothered Copernik, and so he sort of did the math and said, no, if you put the sun in the center of our solar system and everything else revolves around it, save our moon, then it makes sense. And so in 1973, Kopernik would have been 500 years old. And again, rather than buy a statue, plunk it in a park, they said, let's do something. So the Kopernik Society raised the money and built the original observatory, which had 2 domes, which we'll enter in a little bit later, and just a single classroom with a couple of small offices. It was then donated to Roberson soon after it opened. And Roberson ran it for about 34 years. In the 1990s, they had a major capital campaign and expanded it to where we are, about quadrupling its floor space. We added another dome, which has a 20-inch telescope in there, and we'll show you that a little bit later. We also have a geothermal heating system and solar panels, which we'll talk about a little bit later. So usually what people do is then they're coming here for a program, so let's head into our main classroom. So this is we call it Space Science. It's our main classroom. It can hold about 100 people if we set it up in auditorium style. Or if we're doing a class, we can have actually up to 60 students on tables participating in a class. The brick wall to your right here is actually part of the original building, and we have plaques to highlight the donors that helped with the original building and the expansion. And we have throughout the building we have got a number of artifacts of note. This is a picture of Clyde Tombaugh. And Clyde was an astronomer who was the one who first said, look, there's something else moving out there, and he discovered Pluto, which we now know as a dwarf planet. Although a lot of people are really unhappy with the fact that Pluto is considered a dwarf planet, but I'm convinced that if it wasn't for Disney and the cute character, had we called that dwarf planet Aldon or something else, nobody would have cared. But we called it Pluto, then now you're those are fighting words. But anyway, so come on in. We do our Friday night programs typically here, and we've had some great presenters. We've had actually Nobel laureates. Stan Whittingham from Binghamton University has been here. Father George Coyne, who was the Vatican astronomer, has done presentations here. But lately we've been having to do everything via YouTube live stream, so come on over here and get a little backstage tour. This is where the live stream happens. Basically, we've got our camera here, and sometimes we zoom in with presenters, or we'll actually do a presentation. Like last Friday, Roy Williams of our staff did a presentation on black holes, and this is our black hole simulator, and show how black holes really how they affect the planets and the stars that are around there, and that's sort of a little demonstration of that. This is the original cornerstone for the original building in 1973, and one of the things I'd like to point out is over here is a picture of 5 gentlemen. This is Dr. Ed Kozlowski and Richard Miller. They were 2 founders of the Kopernik Observatory. Richard Kelsey, the architect. Mr. Neslick was the general contractor. And this gentleman in the black suit is Colonel James Lovell of Apollo 13. This was 2 years after his Apollo 13 mission. So he was up here to help us install the cornerstone. So now, come on this way. This is actually the original entrance to the observatory. Get a couple of pictures, some plaques we got here. So if you were to come here back in the early 70s and even early 80s, this is where you would have walked in. So come on this way. You can see some. We have some stones here commemorating the early donors. A lot of Polish names, but not all of them are Polish. So we had a lot of community support. And we can walk here into the Ed Neslick classroom. All right, so if you come on in here, this is our original classroom. And right now we've got one of our permanent telescopes. We sort of don't sometimes forget about this. It's called heliostat. Basically, it's a refracting telescope that goes up through the roof. And we took a picture of what we actually have up on top, and you can see here that this little black circle here, that's actually the top of the telescope. And then there are 2 mirrors. This one here is fixed, it stays in position. But this mirror here, we can move around, and we can get it so that the sun's reflects off of this mirror, hits this mirror, and then comes down into the telescope. And then what we're able to do is we're able to project that image against this back wall, so that when we do, the sun is actually greater than my wingspan. It's over 9 feet across, 9 feet in diameter. And unfortunately, I would have shown you a demonstration of that today, but the clouds were getting in our way. So, but this is actually a picture from this Solar Dynamic Observatory, SDO. This comes from a website called Space Weather. And right now, there are a number of sunspots that are on the sun right now. Sunspots are magnetic storms on the sun. This little dot right here is about the size of our Earth. This one, you can probably put about 6 or 7 Earths across the diameter of that sunspot. This is actually over here. This is our portable planetarium. We were very fortunate a number of years ago to get a grant from the Floyd Hooker Foundation, which allowed us to purchase a planetarium. This is the equipment, but we also have 2 inflatable domes that they funded, which we can then take out to schools or organizations. And we hope to get through this pandemic soon so we can go back and start doing our star shows again out in the community. We do actually have a dark room here, and we keep our dark energy and dark matter in there, but out of home. Sorry about that. But we actually do occasionally do some Scout programs here. We do actually a dozen Boy Scout programs and a number of Girl Scout programs, some of which actually where the students actually get a chance to use the darkroom facilities. So come on this way, we're going to head back toward the main lobby. We do have an Earth Science Laboratory. Right now we're in the process of doing some renovations, and but basically that's, we expect the Southern Tier Geological Society are donating some display cases that allow us to show a nice range of various types of rocks and minerals, and so we look forward to having that in place when you all come on back. This is another big part of our, now you see where we're at in the lobby. Here's our computer lab. And the Ahern Foundation funded the 20 computers that we have here. We use this for students. They can either do internet research. There's sometimes some programs that we'll use on this. one of the programs we use very often is called Stellarium, and actually I'm going to invite you to come on in, and I'm going to turn off the lights. Let's see if you can see this. Is me. Why don't you head over that way? So this is the software that we use. Can you see that? Okay, yeah, this is the software that we use to show what's up in the sky at the time. So in fact, what's neat is we can actually go to a particular date and time. So if I go to December 21st, and we go to, let's play here. Let's drop this. We go down here and zoom in. You're going to see what was one dot is actually two. And on December 21st of this year, Saturn and Jupiter will be 0.1 degrees apart. And it'll almost look like one huge star, but it's a double star. Although in actuality, they really are quite far apart. But we hope to do a video live stream on that day. But meanwhile, other things that you'll see here in the computer lab is we have images that we've taken with our telescopes. These are various galaxies that are out there. M51 is actually two galaxies that are crashing in on each other. Over here we've got some nebula. Nebula are the gassy areas where stars are born. And so again, all these were taken with our telescopes here. Over here we've actually got some pictures of Hale-Bopp and I'm trying to think here. Geez. Comet Holmes, geez. Right, there it is, Comet Holmes. And hopefully I'll remember, when we get into the 20-inch dome, I'll show you the telescope that we used to take this picture right here. One of the things I like to point out also to people here in the computer lab is back in 2003, there was a huge solar storm, and this is what the skies look like at Kopernik on that evening. This is Aurora Borealis. Now, auroras you normally see at the poles. Aurora Borealis is the North Pole, or Aurora Australis is down at the South Pole, around the South Pole. But occasionally, this solar storm gets to be so big that it actually will light up the sky, and that's what it looked like here. You can actually see in this picture all three of our domes. All right, so we're going to head out in a moment after you take a look at that. Again, you can see all three, our 14, our 6, and our 20-inch dome. So now we'll head out to our weather station. So we do have an active weather station here at Kopernik. We do actually have sort of an interesting collection of instruments. This is actually a barometer that people would use hundreds of years ago to get a general sense of what's going on. So right now the barometer here is raining. These are the instruments that we're sort of used to back in the 1900s, as it were. But we do have a state-of-the-art weather station here that we'll show you when we get upstairs. And it actually publishes out on our Weather Underground. So if you go to Weather Underground, you put in south of Estill, you can get what's going on here at the Kopernik Observatory. It's currently 37 degrees outside. It's updated every 15 minutes, and if you're going to come up to look around, you can see right now it's cloudy, but or if it's rainy or if it's sunny, it'll tell you that. One of the things we have here is we actually have a NOAA satellite satellite receiving station, and if you go to our website under visitors, go to the weather station, you're able to see up-to-date weather images. So this actually came down early this morning. This was, I believe, from NOAA 15, and you can see that New England was really getting pounded earlier today with pretty heavy storms. Now over here is our Astronaut Hall of Fame. There are actually 4 astronauts that have come from the southern tier that we sort of like to highlight. Eileen Collins grew up in Elmira. Dan Bursch grew up right here in Vestal. These two have since retired from the astronaut corps. Doug Wheelock grew up in Windsor. And Doug Hurley grew up right in Appalachian. And you might remember Doug Hurley most recently as being the commander of the SpaceX Crew Dragon Demo 2 mission. He and Bob Behnken were up on the International Space Station for about 3 months. And they were the first crewed mission on this new capsule. And just a few weeks ago, 4 more astronauts launched on Crew 1. So anyway, Bob and Doug did they call them the Space Dads. They did the shakedown crew for that. Now, we'll talk a little bit about this Kopernik Science Park in a few minutes, but I want to point out 2 telescopes that we've got here. The Kopernik Science Park, we wanted to sort of really make things as accessible as possible. And one of the things that, and you'll see this later when we get into the observatory, that to get to our big telescopes, you really got to climb stairs. And if you are mobility impaired or in a wheelchair, those stairs create a problem. So we ended up, as part of the project, purchasing this specially made just for Kopernik telescope, which is a reflecting telescope. And but what's particularly unique about this is that this is the eyepiece that you normally look into. You just sort of look right there. But whether you're looking straight up, you know, at the zenith, or if you're looking out at something near the horizon, the eyepiece never moves. So if you're in a wheelchair, you can still see it. So this has been a great addition, and it's a super telescope. Another scope that we have, right now we got a spotting scope on it, but this is called a parallelogram. And this telescope, basically, once I find something in the sky that I want to look at, somebody like me can say, oh, let's take a look, and then I can come up here and take a look. And then if I've got a small child, or again, somebody perhaps even in a wheelchair, the parallelogram still keeps that object in the sky, so we don't have to readjust it. So this is another great addition to the Kopernik Science Park. We also talk about the International Space Station. Very often it'll fly by, it actually flies by about 16 times, or actually makes 16 revolutions a day. And sometimes it flies by at night and we can see it. And sometimes we've actually stopped our programs, had everybody go outside, watch it fly by, and come back in and finish the program. But the space station is the largest object we've ever put into space. It's over 100 yards, 300 feet long. And when you see that light going across the sky, it's not like it's got lights on there that's shining down there. You're just seeing the reflection of the sun against the solar panels. Now, if you see a light going across the sky and it's blinking, that's not the space station or a satellite at all. It's most likely a plane. All right, let's head on out. I'm just going to point out we've got our weather station equipment is right there. That's feeding our weather station. And then right over here, the little porcupine antenna kind of thing is that's the antenna that we are using to pick up our NOAA satellites. All right, so we'll head down into the observatory itself. Come on in. It's a little bit of a step up. So this is the original observatory. The original domes, the original observatory was 2 domes. Now we have our 14-inch reflecting scope and a 6-inch refracting scope. And then when Roberson expanded it, we have our 20-inch scope. And this is our 6-inch refracting telescope. It has a 6-inch lenses down at the far end, and then we put eyepieces on here. We then point it to the particular object in the sky we want to look at. Now, this isn't computer controlled per se, but there is a controller on it. So once we find that particular object in the sky, we can say, all right, follow that point in the sky, and it will then continue to follow that throughout the night as the Earth continues to rotate. This is the doors that we would open, and normally it would move to the point of the sky that we want. So It's over 45 years old, so it's a little cranky. But anyway, so this is what our 6-inch scope is like. We also do use it to look at the sun. We can put a solar filter on that, and you can actually safely look at the sun. Very often people, when they'll look at it and they'll say, "Oh, it's cool." Then I said, "No, it's not. It's the sun." It's my little astronomy joke. Very, very little. Now we do actually have some other scopes that we will bring out into the yard. These are called reflecting telescopes, and on what's called a Dobsonian mount. And if you want to actually look inside here, you can actually you might actually be able to see the mirror at the other end. But that mirror is not flat. It's got a bit of a curve to it, so that when the light comes down, it hits another mirror that's right here, and then the image comes out, and we put an eyepiece right here. So we'll head up here into the 14. So this is our newest telescope. This is a 14-inch reflecting telescope that we purchased and replaced our previous 14-inch scope. And it's a wonderful scope. It allows us to see not only planets very well, but also is great for deep sky objects as well. And this one is computer controlled, so you can just pick up the handset, dial in what particular object we want to look at, and the scope will automatically move to where we want it to go. All right. I want to thank Kasha Mazur, who's our videographer today, and making her walk backwards. Now these are also some smaller scopes that we can bring out. And this is what we call a sun funnel. And we use this especially during the eclipse, where you never look at the sun directly with a telescope or even binoculars. But what we did was we got basically a automotive oil funnel, chopped it off a little bit, strapped the eyepiece on down here, and then this is a dollar store curtain that we use and make it for rear projection so that we can actually see the sun right here. So during the eclipse, we were able to watch the progress of the eclipse using the sun funnel. And as often is the case, with live TV, sometimes things happen that you don't expect. One of the things that happened is that the door to our 20-inch telescope closed, and it automatically locks. So I have to get the key, so give me one. Thanks for your patience. All right, so let's go check out our 20-inch. A couple of steps down, and then a few steps up. So this is our 20-inch telescope. It was part of the expansion that Roberson did back in the 1990s. It's a 20-inch reflecting telescope, which means this mirror here at the base is 20 inches in diameter. And then there's a secondary mirror that's right near the top. And then all the light gets sent back down this direction. Now, we used to use this scope to do observing with it, but it's really designed to take images. And so a number of years ago, the Kresge Foundation funded our new CCD, I guess we're locked in, CCD camera and filter set. And so this is a super sensitive camera. But what's interesting about this camera is a black and white camera. It only says, is there light or is there no light? So in order for us to get color images, we have to take a series of images with various filters in front of it. So we actually have a filter wheel here, that has a number of filters so that if you we might take 15 minutes of red, 15 minutes of green, 15 minutes of blue, and then when we compress stack those images together, that's how you would get a color image. So this here is the Dumbbell Nebula. If you're looking at that through a telescope, you'd never discern those colors, but the camera can. Now, as I mentioned when we were in the computer lab, that when we do comet images, we have to use a special telescope, and this is the scope we use for that. The comets are actually quite long, and they take they can take a wide space of the sky. A scope like the 20 looks way has a much smaller field of view. So when we take comet images, we typically take it with this telescope right here. And again, this scope will this opening we call the shutter. And again, depending on where it is that we want to look, we have to move the dome. Very often when people are in here and the dome moves, they feel like the floor is moving because they're not used to the ceiling moving. But in fact, it's just the upper dome. So if you were to come up here on a Friday night, very often the members of the Kopernik Astronomical Society, George Norman, Patrick Manley, Art Casiola, would actually be running this camera, and people actually enjoy watching those pictures being taken. And again, these are some of the pictures that we've taken with this telescope. This is the Eagle Nebula, and you can see when we have different filters on it. This is the Trifid Nebula. This is actually the Andromeda Galaxy. We didn't take this with this telescope because this one is actually, the Andromeda Galaxy is too big for this scope. So we used, I believe, the 6-inch. That's what it would look like, the Andromeda Galaxy using this scope. You only see just the very center of it. And there's the Pleiades. There's the M51 we'd seen earlier in the computer lab. Anyway, so this is what we have here. Again, people ask, if I were to buy this scope, how much would it cost me? This scope and mount system basically will cost about $250,000. We're very, very fortunate that the Kresge Foundation funded this back in the 1990s for Roberson and has been providing us additional funding for the camera and maintenance on this, so we thank him for that. So we're going to head back down. Now, one of the things that I always tell people, Kopernik is more than just 3 telescopes on the top of a hill, and so we really try to help people understand a wide range of science and engineering. And so one of the things we do here is we actually have a ham radio station. There's a ham radio station that has been here for a while, KTZRO Andrew Deskur, which actually, as it turns out, was my father, and who passed in 1984, but was part of also the Kopernik Society that helped build the original observatory. But he was very into ham radio and ham radio satellites. So we've actually had an opportunity to have our students talk to astronauts on the International Space Station through ham radio. And so through this equipment right here, we are able to track the space station. So right now the space station is right now below Australia, and we'll be coming up in about a half an hour or so. It's actually going to be above the horizon here at Capernaum. We won't see it, of course, because it's just too bright, but at night we would be able to see it. So we've actually been able to speak to the space station, but also the Binghamton Ham Radio Club has their residence here, and they have equipment that allows hams to come up and get on the air, and even if you don't have equipment at home, you can, if you're part of the Ham Radio Club, if your license allows, you can remotely connect through your computer and get on the air through here. So it's worked out pretty well. All right, so we're going to sort of finish up our tour outside. past 6 years, I've been working, Kopernik has been working with the Junior League of Binghamton on a fantastic project called the Kopernik Science Park. When I first got up here, we sort of looking at what kind of things does this place need, and one of the problems we had was the area that we had for kids to play in on a break or whatever actually had a bit of a natural spring to it, and so we actually had it combed off because when kids would walk through it, they'd get all muddy. And I said, also we didn't really have much else for them to do, so I proposed to the Junior League of Binghamton, what if we built a playground where we sort of really highlight what aspect of science or engineering, even sort of standard playground equipment, but also we can try some new stuff as well. And this past fall, we finally opened up the Kopernik Science Park, and we took that liability that was the natural spring and the swamp, and we turned it into an asset. It's now a pond where flora and fauna have just shown up on it by themselves. Binghamton University engineering students built a bridge that so you could actually, stand really, in a sense, on top of the water and look down. There are frogs, all sorts of bugs, and it all happened naturally. Very often in the morning when I come up here, I'll see deer or turkey, taking drinks of water out of the pond. So that's been great. So we've taken a liability and turned it into an asset. And but it's been great now that people have come up here. Each of the structures has signage on there talking a little bit about what aspect of science or engineering is part of that particular structure, but also there's a QR code on there that allows you to go to our website and learn more about that particular aspect of engineering or science. Inside our gazebo, we've got images of the 8 different phases of the moon. That was an Eagle Scout project. And we even have a little library where kids, if they want to take a break, they can go and grab a book and either sit or take it home and bring it back or drop it off at another little library. So that's been another popular feature of the park. So finally, today is Giving Tuesday, and this tour here is actually a little way that we could try to give back. It's been really tough for us to not have people up here. We've had to close since March, but yet our bills continue to come in, and obviously we've got to pay them. So if you are in a position to help us out, I think there's a Facebook fundraiser that's running today that you can link to right within our Facebook page. Also, you can go to our website, www.kopernik.org, KOPERNIK.org, and there's ways to donate there as well. Again, any amount is really helpful to us. We are really looking forward to being able to reopen it in the spring, and your donation will allow us to prepare for that, so that I know there's going to be a real interest in getting out and doing things again, and we want to be prepared to offer that. So thanks again for joining us on our tour. I hope you found it interesting and enjoyable, and please check out our YouTube channel. Again, you have access to that through our website, and we look forward to seeing you soon.